Hey everyone, welcome back. Last time we talked about building this mechanical keyboard step by step so you could follow along at home. Now if you don't know what I'm talking about, go ahead and click on this video and watch it. It is an overview of exactly what it is we're building here. Today we're going to be building the bottom half of this keyboard, and basically what that means is we're going to be mounting this PCB or printed circuit board into the bottom of this case. Now before we do that, we're also going to have to install a battery because it is a Bluetooth keyboard. It needs to work without wires. And we're also going to be doing some sound control by putting some lining on the bottom of the keyboard to control excess noise. Now this is important because how the keyboard sounds as you're typing on it is every bit as important as how the keyboard actually feels. Now I wanted to take a quick moment to thank everyone who subscribed to this video. It means a lot to me that you're wanting to come on this journey with me to build this mechanical keyboard. If you haven't subscribed yet and you want to follow along with this mechanical keyboard build, go ahead and hit that subscribe button so you don't miss a thing. So last time we talked about the different sizes of mechanical keyboards ranging anywhere from the 100% keyboard to the very small 40% keyboard. This keyboard is a 65% keyboard, and the reason that I picked this size is that I'm very comfortable with this keyboard. Now this keyboard is obviously the Apple Magic Keyboard, and it is a 60% keyboard. So that means this 65% keyboard is going to be very familiar and very comfortable for me. When buying parts for any size mechanical keyboard, you have to make sure that the parts that you get all fit together. For this keyboard, what that means is that the case here, the PCB or printed circuit board, and the switch plate where the switches go all have to fit together, and they all have to be able to screw down into the case in the same way using the same set of screw holes. There's a company that creates a keyboard called the Poker, and what's interesting about the Poker is that for whatever reason the 60% mechanical keyboard market has de facto adopted how the screw mounts are actually designed. So that means if you're on the interwebs looking for pieces to build a mechanical keyboard and you see that they are Poker compatible, what that means is that they are more likely to work with other Poker compatible components that you can get. Now that we have a PCB with all of the correct mount points for installing into this case, the next thing that we have to consider is the layout of the switches on the board. And this is because given any two boards of the same size, the layout could actually be different. And this becomes important, for example, when selecting a switch plate. The switch plate needs to have all the correct holes to line up with the switches that are installed on the PCB below. It's even more difficult because what they tried to do here was to install a full-size set of arrow keys in an inverse T layout, where most keyboards of this size don't even have arrow keys. And to do that, they had to make concessions. Instead of a normal size right shift key, that's what a normal size right shift key looks like over here. You can get it to focus, there you go. They instead have what's called a 1U shift key. It's a really tiny shift key on the right side. The takeaway of all this is even though you have a board of the right size and the correct mount points, you have to make sure the rest of the components match up perfectly. One thing I should mention about the GK64S keyboard is that the company that made this did not originally create a switch plate that was Poker compatible. And so a lot of people were having to take existing plates and modify them, or for example, cutting them out themselves out of a piece of acrylic. Since then, they have actually created a Poker compatible GK64 plate. So make sure if you're building one of these keyboards to buy the correct one. I'll try to include a link down in the comments to make sure that you don't make this mistake. I actually did and bought a bunch of bad plates. So the first step when building any keyboard is to make sure that your PCB actually works. So what we're going to do is we're going to plug it into some power, and I'm going to do that with this battery here. And what should happen is that when I plug this in, you should see all the lights just come on. And there you go. Now what we're going to do is we're going to make sure that each one of these sockets for the switches actually responds to a signal. And the way that we're going to do that is I'm just going to go ahead and make a Bluetooth connection to it, to my iPad over here, and bring up a keyboard testing app on the iPad and basically go through each one of the switches and make sure that a signal is sent when that switch is actually closed. Now that we have this actually on, let's go ahead and see if we can't pair it. And the way to pair this keyboard with a device is to hold down the function and Z, X, or C keys. It can actually connect up to 3 different devices. So what I'm going to do is I'm going to take switches and I'm just going to go ahead and plug them in to the board, the FN key, And this is going to be the Z key. We'll turn the board back on. Wait for it to boot up. And hold down the FN and the Z key. Let's see if anything happens. Whoa, fun stuff. And I don't know if you can see it here on my iPad, but it now says GK64 KB. And I'll go ahead and tap on that. And apparently we're not connected. So what we're going to do is open up a keyboard testing app. Let's see if I can find one here. It's funny because I have to bring up the keyboard on my iPad because it thinks it's connected to a keyboard, which it actually is. It's just a keyboard that doesn't have any keys on it, so I can't actually use it to type. So I'll bring the software keyboard back up. I'll type in keyboard tester. I already have it. It's keyboardtester.com. Very simple. Launch the tester. And I already have a switch over here on the Z key. I'll go ahead and press that. So I'm typing Z's. What I want to do now is check each of the sockets to make sure that they're working. So I'm going to take a single switch and plug it into each one to make sure that it's working correctly. All right, there you have it. Seems like the board is working perfectly. One other caveat about this board is that even though it has a USB-C power plug here, it doesn't actually take a USB-C cable to power it. The way I found out was that I originally tried to take a USB-C to USB-C cable and power it on, and I'll do that right now. And as you can see here, the board is dead. No lights, nothing. Finally, I went to check the user manual, and in small print, there was a piece of text that basically said you have to use a USB-A to USB-C cable. So what I'm thinking is that this is actually USB-A hardware, only with a USB-C plug. And this is a USB-A cable to a USB-C. I'll go ahead and plug that in. And as before, you'll notice that it powers on and it works. So that's just something you should look out for. I don't think it's just this board. I think other people have complained that their boards were the same way, where you actually had to use a USB-A to USB-C cable. Now that we know that the PCB works with a wire, let's go ahead and try it with a battery. This is the battery that I got for this board. It's from QWERTYboards.com here. It's actually a pair of batteries that are wired in parallel. Each battery has 2,700 megaamp hours for a total of 5,400 megaamp hours. So I have other 60% keyboards that have batteries at around 4,000 megaamp hours. So this should be plenty of juice to power this keyboard. So what we're looking for here, if we flip this board over, is a connector that is marked battery, and that's where we're going to plug the battery in. So that's what these little connectors are here on the board. These are called JST connectors, by the way, and you'll see that this battery also has a JST connector at the end of it. So this one over here actually has little battery markings next to it. This is probably going to be the JST connector that we need. So let's go ahead and plug this in. And with any luck, yep, there you can see that it has powered the board on. So a couple caveats when buying batteries for your board. Make sure that the connector that you're using is actually the correct connector. And this can be hard with JST because there's like a million of them. These are the same size, but I'll tell you right now that this is actually not the correct JST connector. It only works because I shoved it in thinking it was the correct JST connector, and it shoved in far enough that it actually powered the board on, but it doesn't actually click in and stay. So I'm gonna have to do something else to install this battery, either like shove it in, maybe tape it, which would be really hacky, or I could just cut the JST connector off and solder these wires directly onto the board, because it happens that this board actually has two contacts on it labeled battery negative and battery plus, which I've already tested to see if this battery could actually be soldered onto this board, and it works. One other caveat that I should mention is that not all manufacturers have the polarity is the same on their plugs. Sometimes the negative is swapped with the positive, and the only real way to tell is to look at the spec sheet for the battery or the board that you're getting to make sure that the polarities are the way that you think they are. So let's see how this PCB and battery will actually fit into the case. So here you see the case that we're going to be placing all the components in, and you can see that it has this groove for a battery, which is really convenient. And the way that's I think I'm going to have these batteries in here is to place them in something like this, and then maybe use a little bit of double-sided tape to make sure that these batteries don't shift around while you're moving the keyboard around. And the reason I have it oriented this way is that this JST connector is on the left side of the board, and this will leave the wire on the left side of the board, as you can see here. So once this is actually plugged in, this will lie on top of it, just like that. But before we do that, we actually have to do something to the case itself. And what we need to do is sound treat the case so that when you're actually typing on the keys, it's not making, I guess I could say, excess noise. It's not really excess noise, it's dampening the case so that the kinds of noises it makes are a lot more pleasant to the ear than you would otherwise get without treating the case. And the way that I'm going to treat the case is with this material here. I got this off of Amazon, and it's basically cork. And this cork has a sticky backing. You can see this paper here as you would peel it off and it would actually stick to whatever surface. And I think this cork is actually used to line the bottom of drawers. And what I'm going to do here is just cut this cork to shape to fit the bottom of the case. So again, it modifies the sound that will be coming out of this keyboard. And what you'll see here in a moment is I've done a little audio test for the keyboard, both with the cork and without the cork, so you can hear the difference that it makes. So let's go ahead and do that. So you can see here I've installed a couple switches and some keycaps so we can check out the difference between a treated case and an untreated case. The first one that you're going to hear is the untreated case, and the second one that you're going to hear is the treated case. So again, here's the untreated case. And here is the treated case. I'm going to go back and forth between these sounds. So as you can see, or actually hear, there is a difference between the sound-treated case and the non-sound-treated case. Specifically, to my ears, I think it gets rid of a lot of the high frequencies that are generated by the echoes inside of a metal case. And what we're looking for in the final board when you're typing is something that mechanical keyboard enthusiasts call THOCK. A good THOCK actually can differ between different people, obviously. It's a matter of taste. But for the most part, to my ears, the best THOCK are the ones that have low frequencies and none of what I call ping, which is kind of a metallic sound that springs make when you squish them. And, you know, ping by itself is not a big problem until you've got that same sound coming from every single key as you're typing. Then cumulatively, it could just be very bad for your ears. All right, let's put this all together now. As you can see here, I've already soldered the battery onto the board. You're not seeing any lights right now because I actually turned the board off after I soldered the battery in so that it wouldn't drain the battery. The first step is we're going to take the cork pieces that you saw me cut, and we'll go ahead and take the backings off of this and install them into the board. So I'll go ahead and, we'll install them into the case. We'll go ahead and take the backings off here. put that in here. Very nice. And then we'll take the big one, take the backing off of it. I need bigger fingernails for this job. And into the case with you. And push that down to make sure it's got good stiction. Is that a word? Stiction? Very nice. Alright, so the next step is actually getting this board and battery assembly into the case over here. And I didn't have any double-sided tape, but I did have this permanent glue tape stuff. So I'm going to try to use that to actually get the batteries to not move around in the board. It's pretty weak tape, but it should be enough to have it immobilize the batteries so they're not shifting around in the keyboard when you're moving it around. I'll do this battery too. Put the batteries in. Oh, they're already sticking. All right. Very nice. I think that's going to hold really well. Here. Very nice. Okay. Then I'm going to use a little bit of electrical tape just to do some cable management here so that cables aren't just flopping around everywhere. I think I'm going to run these cables just like this. And then along the side of this bottom right here. There you go, that should do it. And then the PCB will mount right into the case there. Now, one thing I have to make sure is that the USB port is actually sticking out, or, you know, centered in the hole here of the case to make sure that I can plug a cable in. Let me get a cable really quickly. This is just to make sure that the cable will actually reach into there correctly. So this one doesn't work because it's bent to this. It's 90-degree cable. This one's not 90 degrees. It's a normal cable. No, still doesn't work because it's got a really thick casing here. Let me try another cable. All right, maybe this one will do the trick. Yep. All that's left is to just screw everything down. And that's what these are for. These came with the case, so we'll go ahead and do that. Now you'll notice with your case that you'll have two types of screws. One of them is, it's like a post with a screw hole at the top of it, and you have normal screws which will then screw down into these posts. And the reason you have two types of screws is these posts are used to fix the PCB down into the case, but when you actually take the plates and need to screw that down as well, you'll use normal screws and you'll screw those normal screws actually into those posts. So let's go ahead and do that. It's really hard to take these little posts and screw them into the case because you can't use a screwdriver on top, because on the top there's actually just a screw hole. So what I think I'm going to do is I'm going to take the normal screws, screw them into the posts first, and then take the entire unit and use a screwdriver to screw them into the case. I'm having a little bit of problems trying to put these screws into the posts. So if you happen to have any children with small hands, or, you know, little people with small hands, now would be the time to get them. Or maybe you know that guy Littlefingers from Game of Thrones? Maybe he'd be really good at doing this kind of thing. Now, what's his name? Littlefingers. Okay, that's 4 or 6. 5. And the last one here. There you go. Go for the first one here. I think the next one's right here. There's 3 is right there. Now you remember the rule for screwing one thing to another, especially if you have multiple screws, is that you want to get the screws into their holes, but you don't want to tighten them just yet. You want to tighten them after all of the screws have been placed into the case, so you don't basically paint yourself into the corner if one of the screws happens to be badly placed, I guess I'll say. There you go. One more. This one doesn't want to seem to go. Oh, because it's the wrong hole. This last one doesn't seem to want to go in. Oh, probably because it needs to shift around a bit. See, this is why you don't tighten all your screws, which they shouldn't be. But this last one just doesn't want to. It's just a little bit off to the side here. There you go. So now I'll tighten them all down. Okay, and now what I'm going to do is I'm going to remove the screw off the top of the posts, and for that I'll just use, what is this? What back is that? So for that I'm just going to use this to hold the post in place while I take the screw on the top off. Beautiful. Awesome. Now just to check, to make sure, I've never done this before, so check and double check. What I'm going to do is take this plate and put it on there. Make sure the holes actually do line up. They look like they do. And I'm going to put some switches in here just to make sure that they plug in and snap into place, and put it on there. Make sure the holes actually do line up. They look like they do. And I'm going to put some switches in here just to make sure that they plug in and snap into place and basically do what I expect them to do. So we'll take a couple here in the middle. The holes are actually larger than the posts themselves, so I'm wondering if these screws will actually do anything when I screw the plate down. Let me see. Yeah, it kind of works. But I'm wondering if it came with a bunch of washers. I'm wondering if that's what I'm supposed to be using here. They don't really specify what you're supposed to do with all these extra parts, or if they're even extra parts. I don't know. A screw went down to the bottom of the board in a little hole. Yay! That means I have to take the entire thing off. Alright, so you can see that I have a couple of switches installed here with the plate, and I think it's evident that the plate, or at least the plate that I got, is not going to cooperate as far as screwing down onto these posts, because the holes for the screws on the plates are much larger than the posts or the screws themselves, which means that if I put a screw on top of there, it's going to do absolutely nothing. It's not going to hold the plate down. You can see right over here that the post underneath the plate is not even aligned when I have the switch actually installed in the right place, so it wasn't perfectly precisely cut. However, since the switches snap into the plate, I'm hoping that all of these switches snapped into this plate will provide enough structural integrity that I'm not going to have to actually screw the plate down. So we're just going to go with that. We're going to have the plate floating above the PCB, but with the switches holding the plate in place. And hopefully the posts that are coming up through these holes will provide a little bit of lateral stability so the plate doesn't slide back and forth, which it shouldn't anyway with the switches plugged through them. So yeah, I think this is going to work. All right, so what I'm going to do now is plug a few more switches in just to test this whole thing out. Let me see if I can find some switches. Yep, they're over here. My desk is getting kind of messy. This post in the middle over here is worrisome. I hope the switch doesn't run up against it too much. I'll go ahead and put in 2 switches here just to make sure that they do not interfere with that post. And it looks like they don't, so I think that's going to be okay. Put one more switch in. Yeah, I think that's going to work. It's really hard to plug these switches into this plate while the plate is kind of floating over this PCB. So what I think I'm going to do is actually take, well, we'll see what happens, but I'm going to try snapping all of the switches into the plate first and then down into the PCB when I actually get to that part. But one more test. Let me put a switch in for the function key. I believe that's this one right over here. Gotta be very careful with these pins. They bend really easily. Let's go ahead and turn it on and see if it powers on. And there you have it. Whew. It powers on, you got the colors. So all that's left now, well, it's not all this, there's just quite a bit more work to do. What we're gonna have to do after this is install the stabilizers for the large keys, and stabilizers are, like, this is part of a stabilizer. It's basically a wire, and the whole point of this is that when you install a large key like this spacebar, the tab key, the enter key, the delete key are the same. Stabilizers are used so that when you push down on one side, they both come down. Both sides come down as a unit. The entire thing comes down as a unit instead of just one side kind of tilting the key. And once we have the stabilizers in, we'll go ahead and get the switches in and then the keycaps after that. And there's quite a bit of work to do with that part, so we'll save that for the next video. So what we've done so far is a great foundation for the rest of this build. I think it's a good stopping point, so we'll stop right here. If you want to make sure to catch the rest of this build process, go ahead and hit that subscribe button so you don't miss anything. And also, if you like what you've seen here and were able to follow along and maybe even learn something, I'd totally appreciate it if you hit that like button and even the little bell icon so that when the next video posts, you'll be notified about it. But until then, stay creative, and I'll check you guys later.